All right, welcome back. So, in the last series of videos, we were talking about the overall process for hypothesis testing, okay? And we put it in sort of the frame of proportions, but the overall process is the same for other situations. The only difference is that we have one formula that we have to use instead of another. And as we get into different contexts and different situations, we'll be using a different online tool as well. Now, the reason why I give you the example of proportions first is because a hypothesis test for proportions, there's a fun name for it, and it's called a z-test. It's called a z-test. And the reason it's called a z-test is because we use the z-distribution and that z-tool that we've used before for calculating z-scores and such. We use that tool to figure out the probability of our test statistic occurring if the null is true. Blah, 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 blah. We're familiar with the z-distribution. That's why we're doing this one first. The process is the same. No matter what you're doing, just slightly different tools and formulas. So no big deal. Okay, so we're going to be using the same example. I'll show you what a proper hypothesis test, a proper z-test, looks like with regard to this example that we were using before. So, in 2005, if you want to skip this, go ahead. I'm just going to read it again. Brown thrashers made up 38% of the birds in northeastern Wyoming based on a proper sample. Okay, being 15 years later, a Wyoming state ornithologist does not think so. They do not think that it's 38%. They think it's something different. So they go out and collect data, and it turns out that when they collected that data, that proportion of brown thrashers was 0.34, or 34%. Now, did this sample occur by chance, or do we have enough evidence to suggest that the norm is no longer the norm, right? Do we have enough evidence to say, all right, 34% might be the new norm? The only thing that's different here now is we got some instructions. Do a hypothesis test using an alpha of 0.05. Okay, so do a z-test. A z-test for proportions. All right, easy enough. And so this is typically how I want to see it done on your end, where we do those 6 different steps. Sometimes you can combine them. As long as I can see your process, that's all that matters to me, because it'll help you organize your thoughts. So step one, we gotta formulate that research question, and it's already kind of given for us, right? Given to us. So the research question is the proportion of brown thrashers in northeastern Wyoming different than 38%, right? Our null value here, our null hypothesis, right? Well, I guess we'll get there, but this is the status quo. Is the proportion actually different than the status quo? We'll take a quick note that the question itself is non-directional, and we're going to be doing what's called a two-tailed hypothesis test, or a two-tailed z-test. All right. Step 2, we got to state our hypotheses. Well, that's simple enough, right? We have our null hypothesis that the status quo is the status quo, right? Everything is fine and is no different than it was before. So the proportion of brown thrashers is equal to what it said it was, right? Originally. So equals 38% or 0.38 since we're working with proportions. Shorthand, you can write it like this. That's okay. But it's always best to kind of be as concise but specific as possible. The alternative hypothesis is what is claimed, is what the researcher is claiming, that it's not 38%, right? And look, the only difference here is the difference in signs. Okay, so that's easy. That's easy enough. Now, here is your formula. Here is your test statistic, all right? Seems kind of weird, so let's break it down piece by piece. Let's see, I'll use this fun color too. All right, so P with a little caret over it, that's called P hat. P hat, okay? And that's just, we can see it here, that's just your sample proportion. That's the stuff that you got. That's the researcher's data. New claim, right? That's the researcher's side of things, okay? And then we have this one, P null, or P naught, P naught, not peanut, but P naught, right? And this is the status quo, right? Just the values associated with our null and alternative hypothesis, right? And then we know that n is just the sample size, right? So this, and I'll zoom in here so we can get it. This is our test statistic, okay? Now it looks very similar. It looks very similar to how we normally calculate a z-score. Same logic, same idea. We're taking what we have, subtracting what's the norm, and then this is also known, and I'll write it over here. I'll write it in this color. This is known as the standard error. Standard error. Now you could go your whole life without really knowing what that means, and it's fine. But this is just another word for standard deviation. Okay. Except we just use the standard error term and this slightly different looking formula for it because we're working in proportions, and we're working more with the central limit theorem idea than we are actual deviations around a mean. Okay, so no worries there. No worries. You can go your whole life without knowing this, and you'll be fine. You can just plug and chug this formula and know that you are getting a test statistic that will eventually lead to, a p-value. Okay, but before we do that, let me write out the test statistic here, and I'll just do it like this. Okay, so z, I'll write it like this. My z's and 2's kind of look the same. That's okay. So let's see. Z equals p hat, our sample proportion, what the researcher found. So that's 0.34 minus the null, the p naught, the null proportion, the status quo. That's 0.38. Okay, and then divided by the standard error. Okay, or just whatever this is, right? So P naught, 0.38. Okay, I'll write it like this. Do you hear that crow out there? Shut up! Sweet. Okay, and then 1 minus P naught, right? So you can kind of see this as this is the proportion of brown thrashers, and then this one here is the proportion of everything else, right? So everything that's not a brown thrasher. That's just sort of the interpretation there. I cannot get over that crow. Okay, and then divided by n. Now n is given to us. So n is a sample size of 1,000. Okay, we'll say that's how many birds are in our sample, right? Okay, and then this is all underneath the square root sign, right? Okay, so again, sample proportion, what we got, what the researcher got, the status quo, okay? The status quo, right? So the number of brown thrashers, or the proportion of brown thrashers, rather. And then 1 minus the proportion of brown thrashers is just the proportion of everything else, right? Proportions have to add up to 1, or 100%. And then our sample size of 1,000. That was given to us. Okay, when you do all that algebra, you eventually get this z equals negative 2.61. Okay, and what do we do with this with z-scores? Essentially, this is just a z-score, but we're kind of manipulating it in such a way to put it in with respect to the null hypothesis. We can kind of see that that's what's happening right here, right? Assuming that our null hypothesis is true, right? That's the norm, okay? Now what we're doing is we're figuring out, okay, based on that, how many standard deviations away is our data, right? That we just found, okay? And already it's pretty far, right? Negative 2.61 standard deviations away from the null, okay? So not the mean, but the null, assuming that it's true, okay? What do we do with that value? Well, this should look familiar. This should look very familiar. Here's that negative 2.61. So that's way over here. That's right here where that blue line is. And then what it does is it just calculates the probability of us seeing our data or seeing our test statistic given the null is true. Okay. Now the only difference is that we have to use this drop-down menu to do a two-tailed test. Because our test statistic is somewhere over here, right? But we are also calculating what if it were over here too. That's fine. That's all fine. It then spits out this value, this area underneath the curve, and that is our p-value. Okay? And again, we'll just round it up to 2 decimal points. That's fine. 2 decimal places. So that's going to be 0.01. All right, 0.01. The computer did all the work for us, right? We just had to provide this value. Okay? Our test statistic. Okay? So our p-value is essentially 0.01. That's all good. Now we got to make a decision regarding the null and alternative hypothesis. Okay? So since the p-value is 0.01 and alpha, our criteria, is 0.05, 0.01 is less than 0.05. We see that p is less than a, right? P-value is less than alpha. Therefore, we reject the null hypothesis. We have evidence against the null hypothesis. Okay? We know that our data is far enough away from the null to maybe suggest that that might be the new status quo, or at least to challenge the old status quo. Okay? Step 6. This is copy and pasted from our template, right? So since the p-value is less than the chosen alpha of 0.05, we reject the null hypothesis that the proportion of brown thrashers make up 38% of the population of birds in northeastern Wyoming at the 5% level. Okay, so that's just our alpha times 100, 5% level. So we're saying essentially that seeing our data, there's a 5% chance that our data, at most, there's a 5% chance that our data occurred by random chance, right? In fact, our p-value is 0.01. So this is saying that there is a 1% chance that what we just saw was totally random, right? Okay. That's sort of the other end of it. The optional bit, there is significant evidence that suggests that the proportion, let's see. What the heck? There is significant evidence that suggests that the proportion of brown thrashers make up 34% of the population of birds in northeastern Wyoming. And that's that, okay? So based on all the stuff that we were talking about, the central limit theorem, all the stuff about proportions, just leads to saying that how much evidence do we have against the status quo, right? How far away is our data from the norm, okay? Did that happen by chance? Well, we have that answer. We have that answer right here. We would say that our data, the chance of our data showing up totally randomly, the data that we collected, that 34%, the probability of that showing up totally randomly is only 1%. So that means that there's another component that's going into this that's saying that maybe this is the new status quo, or at least we have evidence against the old status quo. Okay. All right. So that is that example. Why don't we do a real example, a new example, so you can actually see the process. Okay. So with that, I'll see you here in just a little bit.